In this video, let us discuss about the multilayer perceptrons for simple linear regression with the KRAS. Before that, let me give me the introduction of MLP, multi-layer perceptron. Each MLP model consists of one input layer, several hidden layers, and one output layer. So you can look into this one. Here we have one input layer, one hidden layer, and one output layer. But in MLP, there could be several hidden layers. And the number of neurons in each layer is also not limited. So if you look into this case, the number of input neurons is equal to 3, the number of hidden neurons is equal to 4, and the number of output neurons is equal to 2. Now look at this. Can you figure out how many hidden layers are there? How many input layer? How many output layer? And how many input neurons? How many hidden neurons? And how many output neurons? Yes? So let us discuss about that. Here we have one input layer, two hidden layers, one output layer. And number of input neurons is equal to 3. Number of hidden neurons 4, 4, and number of output neurons is 1. So which means there is only one output, right? Now let us see about the regression. What is meant by regression? The target variable is continuous. What is the meaning of that? The target variable is a numerical data. So whenever we talk about machine learning, there is supervised learning as well as unsupervised learning. In supervised learning, we discuss about regression and classification. And in regression problem, the output is continuous. In classification problem, the output is a categorical data, right? So here for loss function and evaluation metric, mean squared error is commonly used. So just I'm importing the data set from KRAS. From KRAS.datasets, import Boston_housing. So this is a very popular data set that is used to build a linear regression model, right? So I have also taken the same just to make you familiar with this. The next step, what I'm doing now, let me execute the code now. X_train, Y_train, X_test, Y_test equal to Boston_housing.load_data, right? Let me, so hope it is clear, right? So I have loaded the data set now. So let me explain about the data set to you. So this Boston housing data set has totally 506 data instances. Out of that, 404 are training data and 102 testing data, right? And then there are 13 attributes. Attributes are nothing but features which are used to predict the median values of the houses at a location. Hope the data set is clear to you, right? So what are we trying to predict? We are trying to predict the median values of the house at a location, which means the median value in the sense it's going to be a number. Since it is a numerical output, it is a regression problem. And how many features are there? 13 features. And 404 training data and 102 test data is there in this Boston housing data set. Now what I'm doing, I want to know I have to confirm it, right? So just I'm getting the shape of X-train, X-test, Y-train and Y-test. Yes, I'm right. X-train and Y-train has 404 and Y-train and Y-test has, X-train has 404 rows and 13 columns. X_test has 102 rows and 13 columns. Y_train, that is basically the output, right? So the training output is actually 404 and Y_test, that is 102. Hope this is clear to you, right? Okay, so just we have loaded the data set, and the next step what I have done, just I wanted to know the shape of my data, so I check that. Now I'm going to create a model with the help of Keras. So Keras model object can be created with a sequential class. I'm going to make that with sequential, and at the outset the model is empty per se. It is completed by adding additional layers and compilation. Okay, so now if you want to look into this, if you click this link, you can see about the sequential class, right? So just I have added this for your reference. Okay, so just you can have a look at it if you get time for it, right? Fine. So that is clear to you, right? So let me execute this code now. From keras.models, import sequential, model is equal to sequential, right? So I have executed this code. Now I'm going to add layers, right? So here also I have added a link. Just you can go and see into that. Like the core layers are given here, like input, dense layer, activation layer, embedding layer, masking layer, and lambda layer, right? So now what I'm doing, from keras.layers, import activation comma dense, right? So what I'm going to do now is I'm going to make a Keras model with the 2 hidden layers with the 10 neurons each. So first I'm writing like, see, we can write the code in 2 ways. So just I have tried to show you both. Okay, so let me execute this code first. Model.add. What is this model actually? Model is equal to sequential, right? So model.add dense 10. 10 is about the number of neurons, and input shape is equal to 13, right? So here we are talking about the input layer. Input shape should be explicitly designated, right? Now I'm adding activation as sigmoid, and model.add dense 10, model.add activation sigmoid. So I'm adding an hidden layer, and I'm adding another hidden layer, and then I'm writing the output layer. So be careful when you write for the output, there should be only one neuron, because we are trying to predict the median price, right? So there is only one output. So keep that in your mind. So whenever you write for input and output, you should think well and write that, right? So instead of that, we can write it in the single line also. Model.add dense 10 comma input shape equal to 13. Then I'm writing activation is equal to sigmoid, right? Then I have written for 2 hidden layers. Then for the output, again completely it is your choice. Whichever way you are comfortable with, you can go ahead with that, right? So now what we have done, actually we have loaded the data set, and then we have looked at the shape of the data set, and then we have chosen sequential model. We have imported activation, dense, and sequential, and then we have written input, hidden layers, and output, right? Once we complete all this, we have to compile the model, right? So I'm going to compile the model. So now if you look into this, you can see about the optimizers. Keras.sequential, here dense 64, and kernel initializer, input shape, and then here the activation function used is softmax, right? And then here the optimizer is and the losses used categorical cross entropy. So if you go through this, you can come across several optimizers, right? So this I'm adding it here just for your reference. So just you can have a look at it. All right. Now from Keras, import optimizers. So here I'm going to use stochastic gradient descent. So SGD is equal to optimizers.sgd, and I'm adding learning rate over here 0.01, right? Okay. So I think I have to execute this code, right? Then what I'm writing, I have to include loss and metrics. So let me show this to you. Like when I write model.compile, the default optimizer is RMS prop. Since I want to change it to SGD, just I have made a change over there. And then what else is there? Loss metrics has to be mentioned. So that is what I have written, like loss as mean squared error, and metrics I'm writing it as MSC, right? So now just I'm trying to get the summary of my model, and I have used sequential model. Now it is showing for different layers, right? So can you understand this? It is showing for different layers, right? So whatever neurons, whatever number of neurons you have chosen, that is what it is showing over here, right? Once we do that, now we have to fit it with the training data, right? So I'm fitting it with X train and Y train. And what I have done here is I'm just adding a batch size, which is equal to 50. And I'm giving epochs as well as verbose equal to 1, right? So just if you click over here, you can see like model.fit. If you do not give batch size, it will not choose anything. And whatever documentation, whatever arguments you want to understand, that you can go through over here so that you can get a clear idea about it, right? So epoch is nothing but an iteration over the entire X and Y data provided, right? So that's what we are seeing over here. And just we will have a look at it, right? So this will give you a very clear information about all the terms, okay? So no need to worry. Whenever you write a code, just you can keep the cursor over here and press shift and tab so that it will show you the arguments and like how it can be used, and most of the times it comes with examples also. So see, verbose is also given like 0, 1 or 2. 0 is silent, 1 is progress bar, and 2 is 1 line per epoch, right? So the progress bar is not particularly useful when logged to a file. So verbose equal to 2 is recommended when not running interactively. So like this, you can do callback also if it is required, right? So you can use this if it is required. Okay, fine. So just I'm fitting my data now. And now I can see that I have given around 100 epochs, right? So it is done now, right? So if you look into this, like what is the observation over here? Just look into this. The loss was 313, MSC was 326. Now if you look into that, actually there is it is getting reduced, right? So can you see that? Okay, fine. So that's what happening here. Now I want to evaluate my model. So if I want to make the evaluation, so these are the available metrics in Keras, like accuracy metrics, probabilistic metrics, and regression metrics, right? Classification metrics, image segmentation metrics, hint metrics. So just you can have a look at it. Okay, so just you can have a look at it. I hope you can understand, right? So results is equal to model dot evaluate x underscore test comma y underscore test. Okay, you can see the loss and the mean square error over here. Now let me print model dot metrics underscore names. So this is giving me the list of metric names the model is employing, and also the actual figure of metrics computed, right? So from this, I'm getting loss as well as the MSC, right? So hope this tutorial or this session give you some understanding or clear understanding about how to implement Keras in linear regression, right?